going to review some practice questions for exponents from what we just learned from previous classes. And also over here, I just wrote down a summary of the formulas that we just learned, which we'll leave them over there for your quick reference. So the first question, let's take a look over here. It's asking you to evaluate the exponents to 1 or minus 1. So for this one, remember that what we learned about the signs and exponents. If this number n is even, then minus 1 to the even power is always equal to positive 1. And if it's minus 1 to odd power, it will always equal to minus 1. So over here, the first term, minus 1 to the power of 2004, this is the even number, so it's equal to 1. And then the second term, minus 1 to the power of 2005. 2005 is a odd number, so this will be minus 1. And then the third term, it's just 1, right? So it doesn't matter with what kind of power it is, it's always equal to 1. It doesn't matter if it's even or odd number. And then the last term is a bit tricky because the minus sign is not bracketed within the exponent. So it's minus this number, right? So this means this minus sign is also doesn't matter, not related to the exponent. We should evaluate, or we can just write a hypothetical brackets around this number, and we should evaluate this number first. So it's 1 to the power of 2007 again, because it's not a minus number, so doesn't matter the power is even or odd, it's always equal to 1. And then you keep the minus sign, so it's minus 1. Right, and then these two cancel out, these two cancel out. Eventually, your results is 0. The next question, find a positive integer n such that n squared equals 2 to the 6th power. So here, we're looking for either the same base number or the same power, or if the power is the same, then the base must be the same. So here we need to convert something, because on the left hand side n is to the 2nd power, so n squared, but on the right hand side it's a 6th power. So if I have something say n to the 8th power equal to 2 to the 8th power, then if the power is the same, then in order to make the equation true, then I can tell that n equals 2, because the base number should also be the same. But here, the power are not the same at the beginning, so which means we need to do some transformation first in order to solve this question. So what we're going to do, if we can convert this to something with the square, then we kind of able to solve the question, right? So 2 to the power of 6, the number 6 can be written as 2 times 3. So you can kind of factor out a square from here. So then remember one of the formula over here that we can borrow, such that this is also equivalent to 2 cubed and then taking square, right? It's equivalent because 2 times 3 equal to 6, right? And then 2 cubed is number of 8, so it equals 8 squared. So now I have, instead of the original question, now I have n squared equals 8 squared. Then I'm confident to say that n must be equal to 8. Right, so this is how we solve this question. Okay, next one, let n to be positive integer. If we first have this relation, if we say that we have 1 plus 2 plus 3 plus 4 plus 5 plus 6, then taking the square, it equal to 1 cube plus 2 cube plus until we reach a certain number of integers cube. And if this equation is true, how can we find the number of n? Right, so over here, let's just to take a look first on what exactly is the value from left-hand side. So then later on we can decide which n, until which n that we reach the same value on the right-hand side. So on the left-hand side, this is 1 plus 2 plus 3 is 6 plus 4 is 10. Right, 5 plus 6 is 11. So it's 21 squared. I probably don't have a calculator, so 21 squared is 441. Right, so this is my left-hand side. So my left-hand side is equal to 441. Right. Now let's see what happened to my right-hand side. So first of all, I will have 1 cube equal to 1. I have 2 cube equal to 8. So obviously 1 plus 8 won't reach this 441, so I can keep writing at least several more items. So 3 cube is 27, right? 3 squared is 9. 9 times 3 is 27. Four cube is 64. You can use a scratch paper to do the calculation by yourself if you're not certain. But here I'm just keep writing the cubes one by one. And now if I stop here, stop by 5, these 5 numbers added together, it's again, well, you can actually add it together by yourself, but just by looking at those numbers, there's only one number greater than 100. There's a couple other numbers are far less below 100. So the sum of these are obviously still not reaching 441. So maybe let me write one more term and let's check the value. So 6 cubed is 36 times 6, which is 216. So how about now? 1 plus 8 is 9. 9 with 27 is 36. 36 plus 64 is 100. So the sum of all these is 100 plus. So the first 4 terms adds up to 100. 100 plus 125 plus 216. So it's 225 and 216441. So it's 441. So it happened to be the same value from the left hand side. So that I can conclude that in order to make this equation true, this number of n, when reach number of 6, that's your solution. So n equal 6. So when n equal to 6, this is true. Next question. To express the number of 91 as sum of two perfect cubes, and then to express the number of 91 as sum of a positive perfect cube and a negative perfect cube. So anyway, we need to dealing with perfect cube, and we need to know if there are two numbers that can add up to 91. So how about let's write down the perfect cube by the side first. So perfect cube of 1 is 1, 2 cube is 8, 3 cube is 27, 4 cube is 16 times 4, 64, 5 is 125, 6 is 36 times 6, 216. Okay, maybe let's just stop here because to the first question, we need two numbers adds up to -1. So which means if only consider positive numbers, then neither of the two numbers should be greater than -1. So perhaps we can stop by 4 cube and then start checking. Right? So in fact, if I'm adding up the two numbers in any combination, the first try would be 27 by 64 because those two numbers are very close to 91. And in fact, yes, it is because 27 plus 64 is 91. So it is the sum of the perfect cube of 3 and 64 is the perfect cube of 4. So here I got the first question. So the number of 91 is the sum of two perfect cube, which is 3 cube plus 4 cube. Now the second question, of course, we have negative numbers. We can also dealing with negative number, and there exists another combination that a positive and a negative number can also add up to 91. So sounds like we need a large positive number and a relatively smaller negative number, so the difference will be 91 as well. So which means we would first definitely need to choose a number greater than 91. So we can start trying the first option, which is 125. Right? Because if you want one number subtract another number equal to 91, the first number must be a number that's greater than 91. So if I choose 125, maybe let's do it in this way. So if I know this number and I'm trying the second number is equivalent to using the first number subtracting 91. So for example, if I choose the first number to be 125, then the other number, if I want the difference to be 91, the other number must be the difference between 125 to 91. So this 34, and the number 34 clearly not a perfect cube of any number. So which means 125 doesn't work. Right, so this doesn't work. Now let's try the next because we have no other way but just start trying them one by one. So let's try the next. What if the first number is 216? Then in order to make this difference equal to 91, the other number must be the difference between 216 and 91. So if you use this subtracting that, it is 125. And yes, 125 happen to be 5 cube. So which means here, this means I have the first number is 216, subtracting 125, I will get 91. And this is the difference between two perfect cube, which is 6 cube, subtracting 5 cube equal to 91. Right, so this is how we solve this question. Okay, next, given n is an integer such that n cubed equal to 4,913, what is the number of n? Again, if you don't have, here we don't recommend you to use the calculator, otherwise it doesn't make sense. So here really what we want to find is if we can find the factor of this number, right? Because essentially n cubed means this number equals n times n times n. So it doesn't matter what number it is, or you don't even need to worry about the cube at the beginning. At least you need to find the factor of this number, and then maybe different combination of the factors will hint you that what are the perfect cube of n. So first of all, observing from this given number, it's an odd numbers, so the number 2 won't be a factor. Secondly, if you sum all the digits, you probably will learn this later in numbers theory, where you probably may already heard about some of the shortcuts. So basically, if you plus all the digits together, if the sum of the digits can be divided by certain numbers, which means this number is likely can be divided by that number. So the sum of the 4 digits are 17. So it's again, it's not the division of 3. It also cannot be divided by 9. It's neither 11 or 13. So it's 17. It's not 100% true if this can definitely be divided by 17, but we can have a try. Let's try. What if we use this number divided by 17? First, I get the number of 2, so this would be 34. Right, so this 1, 5, 1, 3. Then 1, 5, 1 is likely to be, let's see, 8. If it's 8, should be okay. So 56 and 8 plus 5 is 13. It's 1, 5, 3. It's 9. 63, and then 9 plus 6 is 15. So yeah, so it's exactly true that this number first can be divided by 17. So it first can be written as 17 times the remaining term of 289. And since we already have one factor, 17, then it definitely worth to keep trying to check if the remaining number also divisible by 17. So 1, this is 119. I get 7 here. 7 is 49, and then 7 plus 4 is 11. So it is 17 times 17 times another 17, so it's 17 cubed. So this is how I find the perfect cube that leads to this number 4913 by looking for the factor of this number. Okay, next question. We have two expressions. Let's try if we can get the answer right away without writing down anything. So this means we probably need to use some of the hints over here to take advantage of a known formula, and then looking for the patterns that can easily simplify the expression. So first of all, if I have two numbers divided by each other but they have the same power, this means I can do the division first and then taking the same power, right? So we're here, and then 27 divided by 9 is simply 3, so then it's 3 to the 5th power, right? So this is how I simplify this expression. Okay. The second one, here I have all different bases and different powers. This seems a bit complicated for if you don't plan to write down anything. But I noticed that there's a number 5, there's number 2. 2 times 5 equal to 10. So I will have many a multiple of 10s or many zeros that I can simplify. So if I take 2 to the 5th power, like even though I don't have to write down, but for clarification, this can be written as 2 to the 4th power times 2, another 2. So then this 2 to the 4th power can be combined together with 5 to the 4th power. So basically it's 2 times 5, which is 10. So it's 10 to the 4th power, which means it is 10 hundreds or 10,000 or 4 zeros behind the number. And then what we left is 1 extra 2 here, and the 3 squared here. 3 squared is 9. 9 times 2 is 18, right? And then don't forget I have 10 to the 4th power, which means I have 4 zeros. Okay, so this is how you can, how you're looking for the pattern of the numbers and then take advantage of these summarized formulas to simplify your question. Okay, last one over here, to express the following expressions in terms of the power of 3. So the first one will be relatively easy. So first of all, 1 over 9 is 1 over 3 squared, and then 1 over some power can be written as the minus of this power. So then this is 3 to minus 2, power of minus 2, right? So then this is an expression as power of 3. Next one's a bit complicated, but let's see. First of all, I'm always dealing with the numbers within the brackets. I have 1 over 3 to some power. Again, like 1 over, if you flip over this 1 over something, the power is changing sign. So this is changing from positive to negative, but here the negative will change it to positive. So, or in other words, it's 3. If you flip over, you change sign. So it's minus to minus 2. I'm just writing one more step for clarification, so that minus times minus is positive, so it's 3 to the power of 2. Then minus 3, 3, 2. And then the first part, it's the power of power, it's the multiplication, sorry, where it is, here. So the multiplication of the two powers, so it's a 3 to the power of 2 times minus 3. And then if I have same base, then the multiplication with same base equivalent to the summation of the powers. So 3 plus 2. Then I would just need to simplify my power, so it's minus 6 plus 2, so it's 3 to minus 4. So that's how we simplify this as an expression, or simplify this expression as power of 3. Let's see the next question. So the squares of two consecutive positive integers differ by 67. What are the two consecutive integers? So basically this question is asking for looking for what integer can make, for example, if I have two consecutive integers 2 and 3, then the square of these two integers will be 2 squared and 3 squared, which is 4 and 9, and then they differ by 9 minus 4 is 5. So these two consecutive integers, the square of them are differed by 5. Right, so this is a simple example. Now the question is asking you to looking for the number that which can make this difference to be equal to 67. So of course you can, one way is you can just keep trying the squares of two consecutive integers, like trying 10, 11, 12, like until you find two numbers their difference is by 67. So this is one way, but probably time consuming. There's another way, because we know that the two numbers must be next to each other. So which means if I know one number is n, the other number must be n minus 1 or n plus 1, it depends on how do you want to define it. So let me define it this way. So I have a number of n, and I have the previous number, which is n minus 1. And then this means the squares of two which I don't know what n it is right now, but we're trying to solve or trying to see if we can solve this from a equation. So the square of the two consecutive integers n square, the other one is n minus 1 square, and differ by 67. So this subtract that is 67. Right, so it looks like I can solve, or I can looking for the integer n that can fit into this equation. So let's further simplify this. So n squared minus n minus 1 squared is, if you still remember what we learned in arithmetic, so this is n squared minus 2n plus 1. If you don't remember, you can just do the multiplication in a direct way. And here you probably already know there's a formula that can easily simplify or taking the square of the summation. So then if I further reorder this by put the negative sign together with the brackets, and it's minus n squared, this becomes positive plus 2n, and then minus plus becomes minus 1, and then n squared minus n squared is gone, so I have 2n minus 1 on my left hand side, and this, I want this to be 67, right? So then I can just solve it from here. I will get 2n equal to 68, then I will get n equal to 34. So up to here I already solved it, so the number n must be 33 and 34. Let's verify it. Right, or you can verify it with a calculator. So basically, if I get 34 squared, get 33 squared, and take the difference, you would see that the difference should be equal to 67. So this is how I solve this question. Next one, I have an expression which is 2 squared times 4 squared times 8 squared times 16 squared until times to 1024 squared, and then how to simplify, how to express this, how to simplify this expression as the power of 2, right? Because here only the first term is the power of 2, but then all other terms are the power of a multiple of 2's. So first of all, we can observe the pattern, where you probably already find the pattern that 4 is 2 times 2, 8 is 4 times 2, 16 is 8 times 2. So basically it's 2, right? 4 is 2 squared, this is 2 cubed, this is 2 to the 4th power until the last term. If you don't know it right away, you can just keep adding or keep multiplying by 2 to see how many times you would reach this number. But if you know the shortcut, that 2 to 10th power is 1024, right? So up to here, I'm just rewrite each base number, but remember that we have a square on each base number, so it's square, and don't forget that they are multiplications. Square multiplication, square multiplication. Okay, so up to here, right? So the equal sign means that the second expression is equivalent to the first expression. I'm just rewrite them by simplifying, or up to here it's not really simplified, but by rewriting them to try to give them the same base number, because once I reach the same base number, I can then take advantage of this formula, for example, so that I can convert the multiplication of powers to be the same base, but the summation of the powers. Let me write one more step to write them in a clearer way that they have the same base. So first number is just 2 squared. The second number is 2 squared, 2 squared. which is the power of power, so it's 4. The next one, 3 times 2, which is 6. 4 times 2 is 8, until the last one, 2 times 10, which is 20. Then this is 2 to the power of 2 plus 4 plus 6 plus till 20. Now you can see that this question converted to just looking for the sum of this number, and then you will have the solution, or you have this expression expressed as power of 2. Right? And then this question, if you still remember this, we go back to what we learned in arithmetic. We're taking the sum of a sequence. There are a couple different ways. One way is that looking for the pattern of this summation. For example, here I know that the first term and the last term adds up to 22. The second term, I'm writing one more term over here. The second term and the second last term adds up to 22 as well. The third term and the third last term must also adds up to 22. And then how many terms do I have over here? Well, this is 2 plus 4 plus until 20 for all the even numbers. So it's, if I just want to know the counts, it's equivalent to divided by 2. So it's 1, 2, 3 until 10. So basically there are 10 numbers. You can use whatever way you like. You can just count them one by one. You can use this way to just simply convert them to see there's 10 numbers. Or remember, we had a formula that we learned in arithmetic that we can take the difference from between the last term and the first term, take the step size and then plus 1. This will also give you the counts of a sequence. But anyway, so the counts is 10. 10 means I have 5 pairs. Each pair adds up to 22. So this is 110. So eventually this expression is 2 to the power of 110. The next question, what is the value of x if we have this equation such that 2 to the power of x times 30 cubed equal to 2 cubed plus 2 cubed times 3 cubed times 4 cubed times 5 cubed. So basically I have unknown x on the left hand side of the equation. I have other bunch of numbers in other places. So how to solve this x from here? It looks like we can't just going to solve it directly. We need to looking for a pattern and trying to cancel out some known terms first, and then try to simplify this expression. The first term that I can think about and to cancel out is this term, 30 cubed, right? Because even though I have all different base numbers over here, but they are having same power, so which means later on I can write this as the multiplication of the two base number with the same power. And then if I can make up some number that is equivalent to 30, then which means I can probably cancel this term out and then to solve for the next. So what number can make up 30, or what multiplications can make up 30? 30 clearly is 3 times 10, and then 10 is 2 times 5. So if I have base number of 2 or 3 or 5, they will probably multiply together to be equal to 30. So I do have 3, I do have 2, I do have 5. So this means if I'm writing the first 3 together, don't forget the other term, and then this, because they are having the same power, so it's equivalent to the base, to multiply the base number first. So 2 times 3 times 5 is 30, and the power is 3. Right, and here I get the same, already get the same value compared to the left hand side, so which means my equation can be then reduced to So these two terms are the same term. They can be canceled out. Here, what I'm saying cancel out, it's really just can be divided by the same number on the both sides of the equation. The equation is still true. So then these two terms will be gone together. And then what left is 4q. Now we're very close now. And in order to get the number on the power position, if we have the same base, then the power should also equal to each other from left to right. So which means if we can find a way to convert this number to the same power of 2, then we will be able to solve the question. So number 4 is 2 squared cube, right? And then this is 2 to the power of power, which is 2 to the power of 6. Now I have the same base number, which is the same base of 2, then this means x must be 6. Okay, the next one, find the integer of n such that the 5 to the 96 power is greater than n to the 72nd power, but less than n plus 1 to the power of 72. So basically we're looking for a number such that n plus 1 to the power of 72 should be greater than 5 to the power of 96, then should be greater than n to the power of 72. Right, so at the beginning, first of all, they all have different base and different powers, so which means we need to find a common factor first to try to simplify this question. And here, there's one common thing that if the n or if the base number are positive integers, and if we have if m and n are positive integers, and I have this inequality with powers, this means, and if the powers are also positive integers, then this is true that this is just equivalent to n is greater than m. You will learn this in inequality, but intuitively speaking, if these are all positive numbers, right? If n squared is greater than m squared, which means the number n is also greater than number m, or vice versa. Okay, so here, what are the common factor between 72 and 96? 72, if I'm factoring out, actually I already see the common factor of 24, but let's do this slowly. So 4, if 4 is factored out, the remaining would be 132 is 8. And then 3, actually not only 3 or 6 or 9 is a further factor. But let's take 6 out first and then 3. Okay, 96, I'm taking out 4, I will have 20, 16, 24 left. Right, 24 is 6 times 4, which means the common factor is 24 times 3 is 24 times 4. You will learn this in later class when you learned the least common factor. But here is just a short example of how you can find it by listing all the possible factors and then looking for the common component of the factors. So simply speaking, number of 24 is a common factor. So which means 72 and 96 can be both written as 24 times something. Now, from this inequality, we can rewrite 72 into 24 times 3. So it's 3 and 24. Okay. 96 is 4 times 24. Again, 72 is 3 times 24. So now I have same power from this inequality. So which means, and this is positive numbers, base numbers are all positive numbers, powers are all positive powers. So this means it's equivalent to say that n plus 1. So which means I can remove the same power. So n plus 1 cube is greater than to the 4th power greater than n cube. Now if this is the 4th power, but if this is the 3rd power, then I can do some further simplification, right? So what if I can convert this into a 3rd power? And well, starting from here, it's not necessary to be an integer anymore, but if we just keep the format, so this would be equal to, right, because I just created a 3rd power by multiplying another 1 over 3, because 3 times 1 over 3 equal to 1. 1 can be multiplied in anywhere. So then I'm moving the number 4 back inside. So I can create another number which is 5 to the power of 4 over 3 and the cube. So then this inequality can be further simplified to be 1 n plus 1 should be greater than 5 to the power of 4 over 3 greater than n. So now on the two sides, this just reduced to 2 consecutive integer numbers. So which means if I can evaluate this number, then I will know the 2 neighboring integers between this number. This is very likely to be a decimal number. So up to here, you already almost solved this question. So then you can either use a calculator, or you can try to actually calculate this by hand, because this can be written as 5 to the 4th power to the 3rd cube, well, 3rd root, because it's a power of 1 over 3. So it's 3rd cube of 25. So up to here, sorry, 25 square. So up to here, I'm just using the calculator to get the number, which is 8.5 something. So then, which the integer that between this number would be 9 and 8, right? So then this means n equals to value of 8.